Hello viewers, welcome to the session on Apriori Algorithm in Machine Learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. Firstly, let us look at the definition of a priori algorithm. It is nothing but a classic algorithm which is useful in mining frequent item sets and relevant association rules. Usually, we operate this algorithm on a database containing a large number of transactions. One such example is the items that customers buy in a supermarket. And it helps the customer to buy their items with ease and enhances the sales performance of the departmental store. So let's now discuss the components of a priori algorithm. There are mainly three components of a priori algorithm. These are support, confidence, and lift. When it comes to support, it is nothing but the default popularity of any item. It is the ratio of number of transactions containing item set I to the total number of transactions. And this formula you can see on the right hand side. Similarly, confidence is the likelihood that the customer buys both the items I1 and I2 together. And it is given by the ratio of number of transactions that include both the items I1 and I2 to the total number of transactions. And when it comes to lift, it is the likelihood of a customer buying both the items I1 and I2 together is what number of times more than the chances of purchasing item I1 alone. And it's given as the ratio of confidence to the support. So let us now look at the algorithm behind the a priori algorithm. The very first step is to find the frequent item set. Here the term frequent item set represents the set of items that have minimum support. And the basic ideology behind selecting frequent item set is that a subset of a frequent item set must also be a frequent item set. That is, if set AB is a frequent item set, then both the individual sets, that is set A and set B, should also be a frequent item set. And we need to iteratively find frequent item sets with cardinality from 1 to k, where k represents a numerical value which represents the number of items in a particular item set. After that, we use the frequent item set to generate association rules. Let us now look at the pseudocode behind the working of a priori algorithm. If we need to understand what the CK and LK represents, CK is nothing but a candidate item set of size k and LK is nothing but a frequent item set of size k. So initially we will define L1 as the frequent item set, and then for k equal to 1 to LK not equal to empty set, we will start a for loop and we will generate the candidates tree from LK and store it in CK plus 1, which is nothing but a candidate item set. And after that, we will start an inner for loop in which for each transaction T in the database, we will increment the count of all the candidates in CK plus 1 that are contained in T. After that, these candidates in CK plus 1 with minimum support are stored in LK plus 1. And this goes on repeating until LK is not a null set, and after that we are going to return the union of LK. So let us now understand the a priori algorithm through an example. For this, let us consider a database D consisting of 9 transactions as shown. Here, TID is the transaction ID and list of items that are purchased in that particular transaction ID has been listed here. Now suppose the minimum support count required is 2. Then minimum support is given by 2 by 9. Out of the total transaction we are having 9. So 2 out of 9 is 22%. Similarly, let us support and put minimum confidence required as 70%. Then we have to first find out the frequent item set using a priori algorithm. Then association rule will be generated using minimum support and minimum confidence. So the very first step is to generate one item set frequent pattern. That is, we have already seen in the algorithm k item set. Here the very first step is to generate one item set frequent pattern. Further, we are scanning the whole D for count of each candidate. So we are getting the data set as this. We are getting all the list of items separately, and we have taken the support count of each of the item set, and it has been stored in C1. Please keep on reminding the algorithm so that you can correlate each of them. So after storing this into C1, then we are checking and comparing candidate support count with the minimum support count. Here the candidate support count is greater than or equal to 2 for each and every item. So again in the list 1 item, we are getting all these items. So the set of frequent 1 item set L1 consists of candidate 1 item set satisfying the minimum support. In the first iteration of this algorithm, each item is a member of the set of the candidate. So now in step 2, we are generating 2 items at frequent pattern. Further, we have to generate C2 candidates from list of L1, what we have obtained in the last slide. So from the L1, we are preparing all the possible combination of 2 item sets. And after forming this data set, then we will scan D for count of each of the candidate. And it has been showed here in this particular diagram. And then we need to compare candidate support count with minimum support count. Minimum support count was set to be 2. So all this has been checked and it has been reduced to this particular data set and it has been stored into L2. Let us now look at what we have done in the recently generating 2 item set. To discover the set of frequent 2 item set L2, the algorithm uses L1 join L1, that is self join the table of L1 to generate a candidate set of 2 item set C2. Now after that we have done the transaction in D are scanned and the support count for each candidate item set in C2 is accumulated as shown in the middle table of the previous slide. And after that what we have done, the set of frequent 2 item sets L2 is then determined consisting of those candidate 2 item sets in C2 having minimum support. So the point to be noted here is we haven't used a priori property yet. Now in step 3, we are going to generate 3 item sets frequent pattern. And here we are going to use the a priori property. Firstly, in order to generate C3, we compute L2 self-joined with L2. Then it is going to give us the item sets like C3 equal to L2 self-join L2. Then it's going to provide us all these frequent subsets of 3 item sets. Now the join step is complete and the prune step will be used to reduce the size of C3. Prune steps helps to avoid heavy computation due to large CK. So what we are generally doing here is we will scan D for the count of each of the candidates and scan D for count of each candidate. Then we will check it with support count of each candidate has been noted. Again we will compare candidate support count with the minimum support count. And in L3 we are going to have only those item sets which have satisfied the support count condition. Understand what we have done in the previous slide clearly. What we have done actually here is based on the a priori property that all the subsets of the frequent item set must also be frequent, we can determine that 4 latter candidates cannot possibly be frequent. But how? For example, let's take I1, I2 and I3 with a set of 3 item sets frequently. The 2 item subsets of it are I1, I2, I1, I3 and I2, I3. Since all 2 item subsets of I1, I2, I3 subset are members of L2, we will keep this in C3. Let's take another example where we are having I2, I3 and I5 items in a set, then which shows how pruning is performed. The 2 item set subsets are I2, I3, I2, I5 and I3, I5. But here the subset I3, I5 is not a member of L2 and hence it is not frequent, which means it is violating the a priori property. Thus we will have to remove I2, I3, I5 from the C3. Therefore C3 is only subset I1, I2, I3 and I1, I2, I5 after checking for all the members of results of join operation for pruning. Now the transactions in D are scanned in order to determine L3 consisting of those candidates 3 item sets in C3 having the minimum support. again we will go to next step, that is generating 4 item set frequent pattern. For that, the algorithm uses self-join of L3 to generate a candidate set of 4 item set C4. Although the join results in I1, I2, I3, I5, but this item set is pruned since its subset I2, I3, I5 is not frequent, and thus C4 is a null set, and algorithm terminates here. Having found all the frequent items, this completes our a priori algorithm. So what is our next step? These frequent item sets will be used to generate strong association rules, where strong association rules satisfy both minimum support and minimum confidence. So after knowing all the frequent item sets, we are going to generate association rules. For that, we are having the procedure. For each frequent item set I, generate all non-empty subsets of I. For each non-empty subset of S of I, output the rule S tends to L minus S if support count by support count is greater than or equal to minimum of confidence. That is, support count of a particular item I by support count of particular item S, which is a subset of I. If it is greater than or equal to minimum confidence, then where minimum confidence threshold, then we will consider it. So let's take an example to understand this procedure very clearly. Suppose we are having a L set where it is having all the transaction list in which all the possible frequent item set has been noted, and let's take the I as I1, I2, I3, I5. Then its all non-empty subsets are I1, I2, I1, I5, I2, I5, I1, I2 and I5. So as we have set the minimum confidence threshold, that is say 70% in the initially, the resulting association rules are shown below, each listed with its confidence. So R1 is an item set I1 and I2 tends to give I5. If we are buying I1 and I2, it is saying that if we are going to buy I1 and I2, then we are also going to buy I5. Then its confidence has been calculated. It is subset I1, I2, I5 by subset I1, I2. It is going to become out as 2 by 4. This value has been calculated from the dataset that we have taken in the earlier slides. So it has come out to be 50%, which is less than the minimum confidence threshold. So it has been rejected. Similarly, what is the percentage of buying to an item I2 given that you have already bought I1 and I5? Its confidence has come out to be 100%, then R2 will be selected. Similarly, for item 2 and I5, we are going to buy I1, then the confidence is 100%, then R3 is also selected. Similarly, we have defined R4, where we are predicting whether we are going to buy item I2 and I5 given that we have already bought I1. Its confidence has been calculated and it has come out to be 33%. Since it is less than the minimum confidence threshold, hence R4 is rejected. Similarly, for I2 given that I1 and I5, then the confidence is 29% and again it is rejected. And if we are buying what is the percentage of buying I1 and I5 given that we have already bought I5, it has been calculated and it has been come out to be 100% and hence R6 is selected. So in this way, we have found 3 strong association rules. This is the working behind the Apriori algorithm and then applying association rules. Since we have already understood the a priori algorithm through a numerical example, now let's look at the methods to improve a priori efficiency. For that, the very first method is hash-based item set counting. This is because a k item set whose corresponding hashing bucket count is below the threshold value, then it cannot be frequent. And the next method is transaction reduction. Further, a transaction that does not contain any frequent k item set is useless in subsequent scans. When it comes to partitioning, any item set that is potentially frequent in density base must be frequent in at least one of the partition of density base. And obviously sampling, mining on a subset of a given data lower support threshold plus a method to determine the completeness. And obviously, the next method is dynamic item set counting, because adding a new candidate item sets only when all of the subsets are estimated to be frequent. Finally, it's time for your favorite hands-on session on a priori algorithm in Python. So initially, I am importing all important libraries. See, it has been successfully executed. Now let us read the dataset and show you what we are going to do in this Apriori algorithm. We have already discussed the algorithm, just we are going to see the hands-on session of the same. So I am having the transaction ID and all the different item sets in that particular transaction ID. So in general, there are total of 20 different items in a particular item set. So these are the records of all the transaction IDs. Let me just create an empty list. This is because I want my data sets to be in the list form, because list is easily mutable and our transactions will become easily and it will be convenient for us to do operations on list. So I have converted all the data frame into transaction list. Let me show you this. Yeah, see, it has been successfully executed. Now here comes the main chunk of code where we are doing from a priori package. I'm importing a priori class and creating an object of a priori class. I'm passing it the transaction list that we have taken. We have converted it into a list and then we are passing it as an argument to a priori class. After that, I have set the minimum support as 0.03 and I want the minimum confidence to be 50%. And after that, I want minimum lift of 3, which means it should be sold 3 times than the normal of that. And the minimum length I have given is 2. Let me execute this chunk of code first. See, it has been successfully executed. Now, if I want to see the support, confidence and list of each and every transaction, I just need to execute this thing. And let me print this market basket. Has been successfully executed. For each and every transaction, you can see it has calculated. See, for meat, cereals and pasta, what is the support 0.03 and order statistics, and after that the confidence 0.67 and the lift is 3.59. So it has shown all the results what we have discussed in the numerical example. Now I want to just show the result to the shopkeeper. So what I am doing is I am considering only the item sets, frequent item sets, and storing that into the result object. Let me just execute this chunk of code so that you can get clear idea. See, it has been successfully executed and in total I have get the 24 objects and it is showing the interestingness between the items. See, milk, frozen vegetables and soup, fish, pasta and meat, cooking oil, pasta and meat, again milk, mineral water, frozen vegetables, mineral water, olive oil, frozen vegetables, milk. So this will give basically an idea to the store manager that these are the items which are having interestingness among themselves. We can recommend the store manager that these are the items that he should make sure that should not be out of stock at any cost. And as usual, I have included code snippet for your fast revision. So you can pause your video right here and can take the screenshot of the same for your future reference. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.